Hello, Year 12 doubles, and welcome to a presentation on matrix inversions. So, how we invert 2 by 2 and 3 by 3 matrices. Now, the 2 by 2 one I'm going to show you first because, let's face it, it's not that difficult. It's a quick little step, but it's still worth talking about because I want to talk about why we invert matrices as well and what happens when we found the inverse. So, let's just talk about inverting 2 by 2 matrices first. So I'm just going to, and I know you've already worked through this and you're probably fine with it, but I'm just going to quickly run over it nonetheless. It might be useful. Let's say matrix A is going to be equal to 4735. Now, if we're going to find the inverse for that, the rule is basically you need to do 1 over, well, let's write down what the rule is for a matrix like A, B, C, D. Yeah, if you've got A, B, C, D like that, then you need to do 1 over AD minus BC. That's 1 over the determinant. And then you need to swap these two round and change the sign on those two. And that will always invert a 2 by 2 matrix, any 2 by 2 matrix with those elements. Now, let's try that on this. A to the minus 1 is going to be 1 over 4 times 5 minus 7 times 3 multiplied by, swap these two over, 5, 4, change the sign on those two, minus 7, minus 3. But if we simplify that, sorry about how messy that bit looks, I probably would have normally done the 20 minus 21 in my head to give me minus 1 times by the matrix. And we can times a matrix by a scalar. We just times each element by minus 1. Excuse me. And that gives me minus 5, 7, 3, minus 4. Yeah? Now, what is so special about the inverse of a matrix? Well, simply that this result holds, and it's a very important result. A times A to the minus 1 equals the identity matrix I. Now, what does that mean? Recall where the I is very curious looking matrix at first. It's got 1, 0, 0, 1. But any matrix which is 2 by 2, which you multiply by I, will always return just the matrix itself. It's just like timesing by 1, but in matrix world. It doesn't change the matrix, yeah? Now, what we also have is A times by its inverse equals I. So this is a bit like the reciprocal function, I guess, in multiplication. 5 times a fifth is 1. 7 times a seventh is 1. So you can almost think of an inverse matrix as like the reciprocal of the matrix. Now, let's see if that genuinely works for our A and our inverse A. When we do 4, 7, and sorry about my handwriting's deteriorating again, 3, 5, when we multiply that by minus 5, 7, 3, minus 4, what do we end up with? Well, let's have a look. Never hurts to remind yourself how matrix multiplication works. You get minus 20 plus 21, well, that's 1. Then you're going to get 28 minus 28, well, that's 0. Then you're going to get minus 15 plus 15, well, that's 0. And then 21 minus 20, well, that's 1. So whilst we haven't proved that A times A to the minus 1 equals I, we certainly have verified it in this particular case. I challenge you as a little extension, why don't you try timesing that by that? Yeah, remember the scalar can just sit outside for the whole process, but you'll be doing that plus that times that, you know, and so on and so forth. Try and see if you can end up with I after doing A times A to the minus 1, but working with A, B, C, and D. Yeah, it's a little extension task for you. So yeah, oh, by the way as well, it works either way round. A to the minus 1 times A, also I. And that might be quite surprising because, as we know, matrix multiplication is not commutative. More often than not, A times B is not the same as B times A. In fact, 99.999% of the time, A times B does not equal B times A. It doesn't mean it's impossible. A times B can equal B times A. In fact, when you've found the inverse matrix, it doesn't matter whether you pre-multiply or post-multiply by the inverse, it always equals the identity matrix. Okay, so that's inverting a 2 by 2 matrix, and that should just be a little bit of revision. Let's try and see if we can invert a 3 by 3 matrix. Sorry, just inverting a 3 by 3 matrix. Now, this is much harder to prove because, like I say, the first result, I'll leave it as a little challenge for you. Prove that that equals that. It's not too difficult to do. But for a 3 by 3 matrix, it is a right old pain, and just very heavy on the algebra, so I wouldn't worry too much about it. The main thing is, can you learn the long number of steps which are required? So I'm just going to come up with a matrix, and I'm going to do one where the numbers work out quite nice. I hope you've seen the video as well, which I posted on how to do this on a calculator. I'm sure you'll agree after doing this process, very useful, very useful. You know, one of the key things is make sure you figured out how to do this on a calculator. Okay, so, but you like I've always said, you might not be able to do that if they put a K or an X or a letter in there. Then you might as well chuck your calculator in the bin. Well, I mean, you could still check it by giving the letter a number, but it's just yeah, it's just a bit trickier to do. You're still going to have to work through this process yourself. Okay, step one. Step one is where you find the determinant of the 3 by 3. Now you've already done this. But let's remind you because it's not easy finding the determinant. Okay, essentially what we do, and maybe I should use some colours here, we do that multiplied by, the very top left element multiplied by that times that, and let's do these in blue. That times that minus that times that. So that's what I'm going to do first. So I'm going to do determinant of A, that's how we'd notate it, determinant of A equals 1 multiplied by 1 times 0, which is 0, minus 6 times 4, which is 24. Yeah? And then, oddly enough, and it always feels odd, what we're going to do, oh dear, let me erase a size. Sorry, let me just get rid of my blues and reds here. I'm going to use them again though, but I'm going to show you what I need to do next. Now it's always a minus in the middle. We always use for the second element a minus, and that's perhaps a little bit easier to explain once you've done a vector cross product, because essentially what we're doing here is a vector cross product. But anyway, wait for that. We're now going to do minus 2 times, and then I'll put it in blue, that times that minus that times that. Yeah, it's awkward. And so let's quickly write that down. Minus 2 times, and this just happens to be in the middle when you're dealing with the middle one, minus 2 times, and then 0 times 0, minus 5 times 4, plus, so it goes plus, minus, plus, yeah? And then I'm sure you can guess what's going to come next, or I hope you can. If you've read through the examples first anyway, you'll definitely know. So the last thing we're going to do is plus 3 times, now we're going to be working down below, 0 times 6 minus 1 times 5. That's the last element the last entry we need to consider. So 3 times by 0 minus 5. Okay, so even just finding the determinant is a long process. It's very easy to make a sign error. It really is in this topic. We get minus 24 plus 40 minus 15. And it's no coincidence, because I made sure that this was going to be the case, that we end up with a determinant of 1. Mainly because, just like in a 2 by 2 matrix, once you've found a determinant, you're going to put a 1 over it somewhere in the formula. So if it's like 1 over 7, you're going to end up with ugly numbers, and I wanted nice numbers for my inverse. Okay, so that's just finding the determinant. Now, step 2 is in many ways the worst step of all. It's a step where you're most likely to go wrong. Step 2 is where you form the matrix of minors. Now, provided your matrix isn't called M, it's nice then to call this bit M standing for the matrix of minus, yeah? So it kind of depends what your initial matrix is called, really, but it's nice if you can describe it as M, because it just reminds you this is the matrix of minus. Now, what is the matrix of minus? Well, you know that times that minus that times that, which we've been doing all the way through. That's what the matrix of minus is all about. I am going to have to do various things here, though. Okay, so let's actually try and do this. Right, let me use a red pen. Basically, for the first element, yeah, what you do is you essentially in your mind put a line through there and just look at what numbers are left in this matrix. And then you do the routine, and I want you to get this routine, that times that minus that times that. This kind of cross multiplying that we do all the time in matrices. We just did it to find a determinant. So the very first entry, the top left entry, is where you ignore top row and top, well, first row and first column, and you do that times that minus that times that. And that is, of course, minus 24. So let me write that down. Oh, and let me get rid of those. And that one down there. And so I can write in minus 24 first. Yeah. Your next entry is where you're going to be, if we're looking for what goes here in the minors, then put a line through the row and a line through the column which that entry stands upon. And then we do the same thing. We're going to go that times that minus that times that, minus 20. Oh, I wanted to do it all in the same color, sorry. Minus 20, yeah? It should be exactly the same values as here and here. So I reckon my next value is going to be minus 5. But let me just show you that it is. Oh, so we've got minus 20 in there. Okay, so for the last one, we're looking for this element. So we're going to put a line through the row and a line through the column. And we're going to do that times that minus that times that. And sure enough, we get minus 5. So let's put in minus 5. So that's the top row. Okay, this is obviously a skill. The more you practice it, the better you get, the easier it gets. It is just a routine, but it's a routine which is really easy to mess up. If you don't practice this, you got no chance in the final exam. You have to practice this. This is one of those like practice intensive skills in maths, where if you don't practice it, there's no shortcut to getting good at it. You won't just be good at it because you're clever. No. Okay, because I'm looking for this one, the middle row on the left, I'm going to cross out everything which the middle row on the row and the column which the middle element on the left is in, was part of, and then I'm going to do that times that minus that times that, so I get minus 18. They all seem to be negative numbers for the moment. Oh, right, hang on. Should have got rid of that first. So minus 18. I think it really helps to draw in it. We're now looking for the middle one, so cross out the row and the column that the middle one's standing in. And we're going to do the same thing again. That times that minus that times that, we get minus 15. So I'm going to write in minus 15. And lastly, let's go red again. We're looking for the middle one on the right. So we cross out, and we think that times that minus that times that. That's going to be 6 minus 10, so that's minus 4. So I'll stick in minus 4. And then the same for the bottom row. It gets real tedious. I told you this is a step which is the hardest. 8 minus 3 is 5. You get quicker at it, though. That's the main thing. Finally, we've got a positive number. They're not always all negative, so we get 5 down here. Same again. We're now looking for the bottom one down here. And we're going to do 4 minus 0, so that's 4. Oh. And very last one, finally, we're at the end of step 2. Cross them out. 1 times 1 minus 2 times 0 is 1. So put 1 in there. And we've finally done the longest step, the matrix of minus. Okay, now it gets a bit quicker because we now need the matrix of cofactors. Now, cofactors is where you just do a lot of sign changing. It's just like the swapping and the sign changing in the 2x2, except there's no swapping, it's just only sign changing. And it works according to this. They put a load of pluses in there. I just remember that, which looks like kind of like a face of someone who's completely indifferent. Yeah, you know, like that. Completely indifferent with a little line on their forehead where they're getting stressed because they're doing matrix inversion. So yeah, there you go. Unamused or indifferent. So just remember that, and you'll end up with you know, basically a rule for how to find the cofactors. Now I'm going to call that C, and it's where literally we just change the signs on the ones which part of that diamond. So the negative 20 becomes a positive, and the negative 18 becomes a positive 18. The negative 4 becomes positive 4, and positive 4 on the bottom becomes negative 4. And I've got the cofactor matrix. Now, let's do now the cofactor transpose. That's the last step, really, step 4. Step 4 is where you need to find, well, essentially, should we just write down what the answer is going to be now? The answer is going to be 1 over the determinant multiplied by, sorry, that's just my kids screaming in the background, multiplied by C transpose. C transpose. Now this transpose function, certainly it has lots of uses in matrices, loads and loads and loads of uses. It's where you swap all rows for columns, yeah? It's where you turn every row into a column and every column into a row. So let's see what that means. 1 over determinant's pretty easy, and you do that in a 2 by 2. And in our example, it's just going to end up being 1 over 1, which is 1. I'll write 1 over 1 though, just so you know what you're doing. Now transpose is where you just, if it's a row, it suddenly becomes a column. So minus 24, 20, minus 5. I'm going to write the first row I see as a column. I'm going to write the second row I see as a column. 18 minus 15, 4. And I'm going to write the third row I see as a column. 5 minus 4, 1. And so the final answer, oh, I missed out the inverse sign there, for the inverse of A is minus 24, 18, 5, 20, minus 15, minus 4, minus 5. Sorry, I think my screen's not working that low. I'll have to just move it. Hang on. There we go. Okay, and then minus 5, 4, 1, and we're done. Yeah, that is the inverse. And that's how you find the inverse of a 3 by 3 matrix. Now, it is a long process, but that's why you want to practice it. And you certainly want to know how to find the inverse on a calculator. Okay, because it's a way to check. Okay, so I hope you found that useful. Keep up the hard work. Only a few, you know, only this exercise and the next exercise and a mixed exercise to go, and we're done. And you can have a lovely summer. Okay, bye-bye.